Hi everyone, my name is Dr. Divya Kaur and today we will learn chemical kinetics. So the term chemical kinetics means study of the rate of reaction. Now why do we want to study the rates of reaction? There are many reasons. For instance, to design the catalyst for industrial purposes, to understand the lifetime of a drug in a body so as to improve its therapeutic dosage, and also to design inhibitors to treat certain diseases. And another important thing is to speed up any synthesis of a chemical reaction. So for all these reasons, it is important to understand the rates of those reactions. And the topic we will cover today is rate laws, how to write the rate laws of those reactions, and then what is the order of the reaction, and then the rate constants of those reactions. So let us first define how to write the rate of a reaction. So what is rate? Rate means any change in the entity with time. So in this case, what we are studying is how the concentration of reactants is changing with time. And as you know, in the beginning, the reaction has just begun, which means that the concentration of reactants are maximum. So with time, what is happening is the concentration of reactant is decreasing. However, the concentration of product is increasing with time. So the rate of reaction therefore is the decrease in concentration of A with time, because the reaction increases, product is formed and more reactants are consumed. So that's why this negative sign indicates that. And since the product is being formed, so you will write plus concentration of P with time. So the rate is the change in the concentration of reactant, which is decreasing with time, and the increasing in the concentration of product with time. So now this is a rate of reaction. One of the important points to understand in studying rate law is it is determined experimentally. That means you will know the rate of reaction by deriving it experimentally. So for instance, you do any reactions where there are three reactants involved, A, B and C. And this is a reaction rate corresponds to those reaction. Now this K is the rate constant of that reaction, and the term L, M and N are orders of reaction. So this L is the order with respect to A. The M is the order with respect to B, and N is the order with respect to reactant C. So therefore, what is the overall order of this reaction based on this reaction rate? It is L plus M plus N. So one of the important points you need to know is you cannot determine the order of reaction just looking into this reaction. Let's say I write A plus B plus C is forming products. You cannot write order unless you know the reaction rate of this reaction. So if we know the reaction rate, we can tell what is the order of this reaction with respect to individual reactants. That is, for A it is L, for B it is M, and for C it is N. So now let us begin with the zero order of reaction. So in zero order reaction, as the name suggests, it is the concentration of A is 0. So therefore, the rate of the reaction will be K, A raised to the power 0. And any integer or concentration term raised to the power 0 is 1. So therefore, the rate of the reaction will be equal to K for zero order reaction. Now let's understand what are the units of this rate constant, because sometimes it's asked what is the rate constant unit, right? And since as we know that rate of reaction is what? Change in concentration with time, which can be decrease in the concentration of reactant with time or increase in the concentration of product with time, right? This plus sign indicates that. So therefore, its unit is always the concentration term. Let's say it's molars and the time is in seconds. So rate unit is always molar per second. Now, if you want to know the rate constant's unit, always remember the left hand side units should be equal to the right hand side unit. So therefore, in this case, the units of the rate constant is molars per second. So this is the units of rate constant for zero order reaction. Let's now learn about first order reaction. So again, we are using this reaction. Again, you have a reactant A changing to products. So therefore, now the concentration of A, what is the order with respect to A? It's 1 because it's a first order reaction times the rate constant K. Now let's understand what is the unit for this rate constant. As I always mention, the left hand side unit should be equal to right hand side unit. So what is the unit for this rate? So the unit of rate is molars per second. And we want to know the units for this rate constant, and we know that the concentration of A is having the unit molars. So in order to have left hand term equating to right hand term, what should be the unit of this K? So it turns out it should be per second, right? When you have it's 1 by second, then only the left hand term will be equal to right hand side term. So the units for the rate constant corresponding to first order is second inverse or 1 by second. Now let's begin with the second order reaction. So in second order, as the name suggests, the rate should be K A raised to the power 2. So the order with respect to A is 2. But then you can also have the two reactants participating. For example, you can have A and B both. So the rate corresponding to this will be K, let's say A and B, which means the order is 1 with respect to A and order is 1 with respect to B. So net order again for this reaction will be 1 plus 1, 2. So you can have one reactant involved, or you can have two different kinds of reactant involved in a reaction. Now let's understand what is the unit of the rate constant. Again, left hand side term is the rate, which is change in concentration with time. So the unit for left hand side is molars per second. And in order to have K rate constant, what is the unit of A to the power 2? So it will be molar square. So in order to have this term left hand side same as right hand side, the unit for this rate constant should be molar inverse then per second, right? When you have this unit, then this left hand side becomes same as right hand side. So unit for rate constant for second order reaction is molar inverse second inverse, or you can also write 1 upon ms. So m is again molars and s is the second. So this is all about understanding the rate constants and rate of reactions for zero, first and second order reaction. Now you have seen that the order in these cases can be 0, 1, but that is not necessary. Order can be negative, it can also be 0, and it can also be fractionals. For instance, you can have this rate of reaction where the order with respect to A is half and order with respect to B is 3 by 2. So net order of reaction in this case will be half plus 3 by 2, which is 2. So again, you can have order 2 for any reaction, and you can have fractional orders with respect to each reactant. So I hope you understand this video. Please like, share and subscribe, and thank you for watching.